Hello, this is Lab 5. We're going to start out by just kind of explaining the circuit here that I got going on. We got this red wire, which is supplying power, then going through this resistor, then through the capacitor, and then to ground. And then these two green wires here are reading in our VN, which is right here, and our VC, which is this wire here. And then basically when, this is the 10 kilo ohm resistor, we can replace this with the 100 kilo ohm resistor when the time comes. All right, so here we're going to get into the simulation. If you look at the code here, we're defining our V, our R, and our tau, our C and our tau, time constant, and we're defining the length of time that we're going to be running the simulation for. And then basically this VC is the current, or the voltage across the capacitor, which is defined by this formula here, and then the MATLAB code is going to plot it versus time. So now we're going to take a look at the results, and basically what we see is that this red line defines that at t equals 0, it jumps straight up to 5 volts, which is expected based on the raw data. This blue line with the 10 kilo ohm resistor is going to take a little longer to get up to 5 volts. And then this orange line, the 100 kilo ohm resistor, takes a lot longer than that to get up to 5 volts, which makes good sense because the higher resistance, the harder it's going to, or the longer it's going to take to get to 5 volts and get to steady state. All right, so now we're getting into our Arduino code here. At the top, we defined our resistor. We start with the 10,000 kilo ohm one, and then our capacitor and our time constant. Here we defined our baud rate, defined the pin modes, started with it low for 5 seconds, and then in the loop, we have this while loop, which basically turns the VN to be on, and then prints out the readings from VN and VC. And then down here, VN is off, and it reads VN and VC again. And then our serial monitor displays VN going 1020, 0, 1020, 0, which is about right, because there's 10,023 bits. And then VC kind of flows with the same pattern here, except doesn't quite get all the way up to 1023, which is about right. All right, so now we've replaced our 10 kilo ohm resistor with a 100 kilo ohm resistor, which means our time constant's much longer. So VN is going to take a lot longer to get to 1023 bits. You'll see that it takes a little bit longer also for VC to get up there too, but it only gets up to about half of the value because now it's a lot more resistance. It lasts for a lot longer, and then it slowly depletes down to 0. And then VN is going to go back up to 1023, and it's going to go back up to about 500 bits, but never going to reach the full capacity because it has already gone through a resistor. All right, so now we've switched back to the 10 kilo ohm resistor, and now we're looking into the processing side of things. So we set the baud rate to 115,200, and then if you scroll down, this was all straight from the GitHub website. Basically what I did was use the line function to set my axes. So I have 1 volts, 2 volts, 3 volts, 4 volts, 5 volts, all labeled along the y-axis there. And then I made the legend right here, which basically places it in the processing window towards the top where it says VN with a certain color and VC with a certain color. So for the 10 kilo ohm resistor, the output looks like this. It goes pretty quickly, but you'll see V in as the red one is at 5 volts, then 0 volts, then 5 volts, etc. Whereas VC kind of bounces up, doesn't quite reach 5 volts, and then goes back down. Sort of looks like the curve we would expect it to look like. And here we can see the same type of thing with the 100 kilo ohm resistor. Everything's just a lot slower because there's more resistance, time constant's higher. So yeah. All right, so now we're doing the MATLAB experimental part with the 10 kilo ohm resistor. So we defined our R here. We used option 1 because it's from our local machine. We converted to volts by dividing by 1024 times 3. And then if we look at our screenshot for this, we can see that it looks about right. It's very similar to the processing, except it's all on one graph here. Voltage is on the y-axis, time is on the x-axis. All right, and finally we have our 100 kilo ohm resistor, and we can see that when VN is 5 volts, VC comes up and hovers around 3.5 volts roughly, and drops back down. This matches up pretty well to our simulation data where VC took a lot longer to get up to close to 5 volts and back down a lot longer than it did for the 10 kilo ohm resistor.